Problem number 4, I want to find the missing pieces here in these triangles. So when I look at letter A, what I see is I've got a 45, 45, 90 triangle, which means I don't really even have to use trig. I could just use my relationships for those triangles. I know the way those go. It's always these two sides are the same, and the hypotenuse is square root of 2 times as much. Well, I was given the hypotenuse as 18. That's the x root 2 side. I can therefore solve for x by dividing by root 2, and I have the information I need. I'll have to rationalize the denominator here. That gives me 18 root 2 divided by 2, which simplifies to just 9 root 2. But there's my x. This side here, this x, must be 9 root 2. And the y is obviously the same thing. In a 45, 45, 90, those are the same length. So y would also be 9 root 2. There's my answers. I could have used trig. Instead, I could have written myself a little statement like sine 45 degrees equals y over 18. And then I could have solved this thing for y by multiplying by 18. Well, I know what sine 45 degrees is equal to. It's equal to radical 2 over 2. 2 would go into 18 9 times, and there's my 9 root 2. So I could have also used trig to solve this problem. In letter B, if that big angle there is 150 degrees, that leaves me with 30 degrees for this little angle, which means I am looking at a 30, 60, 90 triangle. Once again, I don't really have to use trig. I could take advantage of the fact that in a 30, 60, 90, whatever the short side is, the medium side, the 60 degree side, will be root 3 times as much, and the hypotenuse will be twice as much. So the 7 is what they gave me, the hypotenuse. That would be the 2x side in this picture, which means, of course, the short side, the x, would be 7/2. Be careful, because the x in this picture is not the same as the x in the original picture. In the original picture, the short side, the one opposite the 30 degrees, is the y. So basically what we have just figured out is that the y is equal to 7/2 in my original picture, the short side. X is the medium side. Now be careful here. I'm in the second quadrant, so obviously x is a negative number. As far as the value, it's the medium side. The medium side is root 3 times as much as the short side. So all you'd have to do is multiply the short side by root 3. That would give you 7 root 3 over 2. Here then are the final values for x and y. Of course, again, you could have used trig. You could have said something like sine 30 degrees is equal to y over 7, and multiply both sides by 7. We know that sine 30 degrees is equal to 1/2, and so we'd have y equals 7 times 1/2, in other words, 7/2. You could do something similar to find x. Once again, though, you'd need to keep in mind that because you're in the second quadrant, the x is going to come out negative. Problem number 5, we're given some tables here. We want to fill those tables out by hand. So we're just going to be plugging in some values. Problem A, y equals 4 cosine x. First I want to plug 0 in for this x. Well, for cosine 0, I should refer to the unit circle. That would be this spot right here, which is 1 comma 0. The cosine value would be 1, and then I'm multiplying that by 4. So the value I would fill in here is 4. 4 times 1. Pi over 6. So cosine pi over 6. Pi over 6 is 30 degrees. Looks like cosine pi over 6 is root 3 over 2. But then I would be doing 4 times root 3 over 2, which is going to come out to be 2 square root of 3. Next, I'm filling in pi over 4. That's 45 degrees. We've done this many, many times. Cosine is 1 over root 2, which rationalizes to root 2 over 2. But as always, I'm multiplying here that answer by 4. 2 goes into 4 twice, and so my final value here would be 2 square root of 2. Let's see, for pi over 3, that's 60 degrees. I can get that off of this picture here. The cosine ratio would be 1/2. And obviously 4 times 1/2 would be equal to 2. And pi over 2, that's here on the unit circle. That's the point 0, 1. The cosine value is 0, and 4 times 0 is 0. So we've got that first table filled in. Letter B, y equals 2 times sine x plus 2. So again, we'll be calculating some sine ratios, multiplying them by 2, and then adding 2. Let's do the first and the last, the 0 and the pi over 2. Those come from the unit circle. So I'll draw my picture. Here's the point 1, 0. The sine ratio is 0. 2 times 0 is 0, plus 2 would be 2. And then let's concentrate on the back one here. This is the point 0, 1. The sine ratio is 1, times 2 is 2, plus 2 would be 4. How about pi over 6? That's 30 degrees. And so the sine ratio comes out to be 1/2. Now I'm taking the 1/2, I'm multiplying it by 2, and then I'm adding 2. 2 times 1/2 is 1, plus 2 would be 3. Let's use pi over 3 next because I can get that from that same picture. Pi over 3 is 60 degrees. The sine ratio would be root 3 over 2. So 2 times root 3 over 2 plus 2. The 2's would cancel. I can't actually combine the root 3 and the 2, so I'll just have to write it down. Root 3 plus 2. And then pi over 4. Let's see, I can use this picture up here. Sine ratio is 1 over root 2 or root 2 over 2. It's going to be a similar calculation here. Those 2's are going to cancel and I'll be left with root 2 plus 2. I could get decimals if I wanted to. The direction said to give exact values. And then part C works a little bit differently. I'm going to have to double my angle first, double my x, then stick it into the cosine function, and then multiply by 3. Well, doubling 0 doesn't do anything. 2 times 0 is just 0. When I take the cosine ratio for 0, I get 1, and 3 times 1 is 3. What about this one at the end here, the pi over 2? Again, first I would double it. What I'm working out is 3 times cosine of 2 times pi over 2. When I double the pi over 2, I get pi. Cosine pi, that would be over here. That's going to be -1 times 3 gives me -3. Okay, let's move on to pi over 6. Remember, I'm calculating 3 cosine of 2 times pi over 6. I have to double the angle first, then I can draw my picture and get my ratio. 2 goes into 6 3 times, so this actually means I need to calculate cosine of pi over 3. Pi over 3 is 60 degrees. The cosine ratio for pi over 3 is 1/2. And then I take that answer and multiply it by 3. 3 times 1/2 would be 3/2. How about pi over 4? 3 cosine of 2 times pi over 4. Well, 2 times pi over 4 is pi over 2. That's a unit circle situation. Cosine of pi over 2, I would come up to the top of the unit circle. Here's the point 0, 1. The cosine ratio there is 0, and 0 times 3 is 0. Lastly, I have pi over 3, so 3 cosine of 2 times pi over 3. 2 times pi over 3 is 2 pi over 3. So I'm going to have to figure out that answer. Let's draw a picture. 2 pi over 3, that is 120 degrees, so over here in the second quadrant. That means my reference angle is 60 degrees. When I drop the perpendicular, I have formed a 30, 60, 90 triangle. The 1 would be negative here in the second quadrant. The cosine ratio looks to be -1/2. So this comes out to be 3 times -1/2, which works out to be -3/2.